Hello everyone, welcome to MMBS 111, Introductory Microbiology. This is the final mini lecture for Chapter 9. This is 9.3, where we're going to be talking about chemical agents in microbial control. There are 5 learning outcomes for this mini lecture. First, name the characteristics of a good chemical control agent. Second, describe the 3 levels of chemical decontamination procedures. 3, name the 10 germicidal categories of chemical agents. 4, identify the chemical agents capable of sterilization. And finally, identify other antimicrobial agents. All right. So chemical agents that we use to control microbes can occur in any of the states of matter. So we could use a liquid, some are gases, and even others are solids. And they range in effectiveness from disinfectants and antiseptics to sterilants and preservatives. Some of our agents are going to be found in aqueous solutions. That means that they are a chemical that has been dissolved in pure water as the solvent. And others are going to be found in tinctures, and these are chemicals that are dissolved either in pure alcohol or a water-alcohol mixture. There are a number of things that we need to consider when we are selecting a microbicidal chemical. One of those things is rapid action. So even in low concentrations, are we going to get effective microbicidal action in a fairly short amount of time? We also want it to be soluble in either water or alcohol and be stable over the long term. We don't want these substances to break down quickly, because then that's going to limit their effectiveness. We want them to be broad spectrum, so we don't want specific targets. We want them to work generally and be effective against a wide range of organisms. And we want this to occur without toxicity to human and animal tissues. We also want a chemical that is going to penetrate inanimate surfaces and sustain persistent action over a period of time. We do not want them to become inactivated by organic matter, so we want them to resist that activity. We also want them to be non-corrosive and non-staining to the properties that we're trying to treat. Also, we hope that they have sanitizing and deodorizing properties, and that they're affordable and readily available. At this point in time, there really is no chemical that can completely fulfill all of those requirements. Glutaraldehyde and hydrogen peroxide are the chemicals that come closest to that. And we're going to look at a number of chemicals in this chapter. So germicides are evaluated in terms of their effectiveness in destroying microbes in both the medical and dental settings. And we have a number of levels of germicides that we're going to look at. So high-level germicides kill endospores and can be used as sterilants. There are very few of these. Intermediate-level germicides kill fungal spores, but not bacterial spores. They also kill resistant pathogens and viruses. And then our low-level germicides are going to eliminate only vegetative bacteria, vegetative fungal cells, and some viruses. And these are most likely the enveloped viruses. There are a number of factors that will affect the germicidal activity of the chemicals that we're going to look at. The nature of the microorganism being treated and the material being treated. So we know that each microorganism has a different level of resistance, and some are more resistant to certain substances than others. The degree of contamination. So what's the size of the population? Is there extensive contamination on this site, or is the population small? The time of exposure. So how long is it going to take? How much time do these organisms need to be exposed to this agent? The strength and the chemical action of the germicide. So what is the target? The chemical strength or concentration, the length of exposure, and then the composition of the material being treated. So are we looking at solid, surface, porous substance? So the next few images come straight from your textbook. This is table 9.9. And these tables list the chemical agents that we typically use to control microbes, and what's their mode of action, what are some of the limitations and indications for use. So you can see we have bleach, iodine, hydrogen peroxide, some aldehydes, ethylene oxide, and some other gases. And each of these is going to have a different mode of action against a microbe and different indications for their use. Some can be used on tissues, others must be used on surfaces, and then some limitations to their effectiveness. And you'll notice the same here in the second part of this table. We've got a number of chemical agents listed here: carbolic acid, chlorhexidine, alcohol, detergents, and then heavy metal compounds. Each of these is going to have a different mode of action against the microbe, a different target, and then certain indications for their use and some limitations to their effectiveness. So make sure that you review this table and that you become familiar with some of these major groups of chemical agents and their mode of action, their limitations. Okay. So this image is also from your text, and this illustrates how certain chemical agents can impact proteins and enzymes within cells. So hopefully by now you're familiar with the native state, right? This is the state of the enzyme or the protein that makes it effective and active. So there are three ways that chemical agents can target proteins and enzymes in cells and contribute to their inactivity. The first is complete denaturation. The tertiary and quaternary structure of that protein essentially falls apart. It's no longer folded in its native state. It's completely ineffective. The second way is to change the shape of the active site. And by doing that, the enzyme is no longer able to perform its function because the substrate that it acts on is no longer able to bind to the active site. So the reactions have been stopped. The other way is to block the active site. So certain agents are actually going to bind to the active site, similar to competitive inhibition, and those agents are going to remain on that active site. This normal substrate will not be able to bond to those active sites, and the action of the enzyme has been stopped. There are a number of other antimicrobial agents that we can use, dyes, acids, and alkalis. Remember, pH plays a role in the survivability of organisms. Certain organisms prefer certain pH, typically in that neutral area. So high or low pH can destroy or inhibit microbial cells. We don't use acids or alkalis a lot because they are corrosive and caustic, so they break down materials and tissues. They're also not very safe in the environment. Dyes can also be used. Dyes are typically active against gram-positive bacteria and fungi. They have very limited application though, because they do stain whatever they're applied to. So they have a very narrow usefulness. And that is the end of mini lecture 9.3. These are our checking in questions. Make sure you go through those questions and that you're able to answer them correctly. Remember to go back and look at the learning objectives for this section. Make sure you've mastered those topics. And here's our critical thinking question. Proper hand washing, as we discovered in Chapter 1, has for many years been known to reduce microbial contamination during invasive medical procedures and decrease the microload on the skin of the hands. What effect does hand washing with soap have on microorganisms? The answer to this question is on the next slide. So work through the question, and then you can go in to the Blackboard course for week 9 and find the answer there. And hopefully this video was helpful.